Yes, I'm Bob Corrusso. I was with Bucyrus from 1950 to 1983. Spent some time in the machine shop assembly area, and then into management, into industrial engineering. In '83, we continued to get together as a group. We called it a retirement group, and we meet twice a year. This being 2011, we've been meeting for 28 years, and our reason for putting this together is to record what things happened in Evansville and what happened with Bucyrus Erie. Back in the early 1900s, a Ruston machine company from England and Bucyrus from the United States formed a company called Ruston Bucyrus. Then in the around 1910, they brought on Erie Manufacturing. Then it was called Bucyrus Erie. In 1914, an Evansville plant was built. This plant was to build the medium machines. Bucyrus building the large ground earth removing type equipment, Bucyrus doing the metal drag lines and shovels, and Erie doing the smaller models, talking less than 3-yard machines. Okay, back in the early years of Bucyrus in Evansville, the Panama Canal was being built, and they used draglines, shovels from our plant, and some larger equipment from Milwaukee and some from Erie. That was one of the big projects. Then in the First World War, they got into scraper blades and bulldozer accessories, made shells during between the First and Second World War, and other Army type items like they had some, I mentioned again, bulldozer blades, large cylinders for units. From that, we got the Evansville, after the wars, Evansville got into a lot of construction machinery. By that I mean drag lines called the 61B, 71B, and 88B. They handled buckets between 2 yards and 5 yards, and they were a multiple type machine that could be used for shovel or dragline applications. Well, that was our main line. Then in the 30s, early 30s, the coal mines had a need for drills, blast hole drills, rotary drills as it's called, and the domestic use of sputter drills for water wells and so on. They were built here. The rotary drill was a 10R. The sputter drills were 20 and 22 Ws. Let me explain the use of a drag line. A drag line was a machine on crawlers that was able to throw a bucket out and pull back towards the machine and pick up overburden. These were used mostly in building of roads and in coal mines. The coal mine application was to remove all the dirt off of the coal seam, throw it to the side, and then these same type of machines, the 71B and the 88B, the 61B, had a shovel front end put on that they could go in after one of the rotary drills went through and drilled and blew up the coal seam. The shovel would pick up the coal and load it onto trucks to be hauled to destination, to railroad, or so on. Stripper pits were all over the Midwest, Indiana, Kentucky, Tennessee, Pennsylvania, and they followed a coal seam. They would go out ahead of the coal seam and do some drilling to keep up with the seam, and then they would take the overburden off and then shovel the coal. Again, to explain the function of the 10R drill, it was used by a rotary bit with water. The water would be forced down with the bit. This would bring the mud out, and that's how they could get their depths. They would put additional stems on the drill. This was on rubber. It could be moved around, and that was one function ahead of the coal seam. And then the after job of a rotary drill was to blast the coal seam into pieces so that a shovel could pick it up. This pictured here is a different type of drill. It was a sputter drill where it would hammer into the surface, getting the depth that way, and it was mounted on rubber or on a trailer, or some of them were actually mounts that could be set on site for the deep hole drilling. Okay, I'd like to explain again what a shovel, or 88B, which was made in Evansville, one of the money makers for Evansville, because we shipped them all over the world, wherever mining was done. The shovel part of it was different size buckets, and they ran from say 2.5 to a 5-yard bucket. That meaning by 2.5 to 5 meaning cubic yards. The bucket was mounted on a stem that would allow them to pick the overburden, or the coal up, or the overburden, whatever they was doing, and move it to a vehicle or to the side and dump it. The back of the bucket would open up and dump it. Now, this being a friction drum type machine, it operated with different drums that would, if you was to hoist, it would lock the clutch, the release, and you could hoist the bucket, and if you wanted to release, you go the opposite. So the things that changed on this basic unit was like the treads. If they were in solid areas, they could go with like a 32-inch tread. If they were in mud or soft ground, they would extend these treads, and they would be something like 42 inches. They also had a system, if they wished, they could put wider axles in here and give the base a bigger base if the terrain called for it. Now, also in these, they could have different types of engines put in them. Diesel engines, they would whatever the purchaser would want, we'd put that type engine in. They also had different type generators. They could go with air conditioning. There was this friction machine had a operator, and it had an oiler. They always had an oiler on these friction machines. The oiler, other than doing oiling work, was a safety man, because you couldn't always see what was behind when they would swing it. Okay, this being the 88B dragline, which also can be a crane. Let me explain this dragline function. It again works on friction and brakes, and they would throw this bucket out by leaving the cable out, which is around an inch and a quarter cable. Leave it out, pull it back, and then by releasing this cable here, dump the bucket. Now, they had these sharp booms on the drag lines, but now if this machine was used for construction, they could increase this boom length with sections in here, with center sections that would take it up for like construction of buildings, moving steel up, moving concrete up, and they would then use a ball and hook on there or a concrete bucket to take concrete up. Now, these machines were built on tracks for this model is, but they were also mounted on barges. They would not have the tracks on them. They would just have a pedestal that would be welded to a barge top, and they could unload sand or drench sand out of the water and dump it into barges. Other type applications were again, like I explained before, increasing these tread sizes, increasing the axle to get a different function. One thing I'd like to show, in the early days of the Bucyrus Erie, they used this logo, and then in the latter years they went to a new type logo. This was about the time that they got engineered into hydraulic machines. This unit also could be mounted on a railroad car to pick up, this 88B was a little large for that, but the 61 and the 54 and the smaller models could be used for picking up off of the railroad car. This again explaining the drag line. They would have a 30-foot section here, a 20-foot section, and maybe a 10 in between or a couple 10s. This would allow you to throw this bucket out 60 or 70 feet and bring it back, pulling the dirt up towards the machine and then dumping it to the side. So that was the drag line. Here is a picture of a early machine before we had the sheet metal cabs, and in the later years they went to fiberglass, but the early ones were made from wood siding, then they went to corrugated siding, and this one here, you can see it was a steam operated with coal. They burned coal in there. That'd give them their power instead of a engine. This 50B here, and you can see the other friction machines sitting in the yard there. This was used, this right here was a test weight, and they were testing the machine out. And I think this picture shows you the different sections that can be added in. And there's another thing that a crane can have to give it additional height. It can have what they call a jib on it, and that would be the jib part. Now, one of your early machines Bucyrus built was they put it on a railroad track. This was due to the terrain, that it was maybe too soft for treads. They would use the rail track, keep putting track on, and then digging out overburden for either highways or railroads. Okay, in the 60s, and they designed friction machines were sort of on the way out, and hydraulic machines came into the picture. You can see here they had a cylinder instead of cables to operate the up and down to do the bucket lip stem, they called the bucket stem, and these were hydraulic. They had a multitude of cylinders. They had a diesel engine to operate the oil pressure, and this machine also come with times when they got rid of the oiler on machines. As you remember, I was telling you about friction machines always had an oiler on the rear. When they went with hydraulic, they then just went with an operator, and that was a change in this. This then went into the coal mines. They had these backhoes. They had front loaders, again going hydraulic to speed. This went to rubber mounts and so on. So that was in the 60s. These cylinders were manufactured in Evansville. It was a stem and a cylinder housing with glands and O-rings in it, and they were chromed and then polished, and these stems here on this machine, or this rods on this machine, could be around 2 inches, 2.5 inches, with this outer housing 6 to 8 inches, the size of the machine. These came out in, they was called the 30H and the 40H and so on. So it was, each machine was just a little larger in the capacity. Along with the hydrocranes, or with the hydraulic machines, we had what you call a 45C and a 35C, meaning tons, 45 ton and 35 ton. These box boom type machines had hydraulic cylinders within the boom, and some of those cylinders would run 20, 25 feet long to extend the telescoping of the boom. Now these were rubber mounts. They had 3 sets of duals in the back and 2 axles in the front, which was on the 45C. The 35 had a single axle in the front. Now these were, you could permit them on the road, and they came with the construction of buildings. They didn't have to set up a big rig, and they could put this in. It had outriggers on each side that would extend, that would level the machine, and then they could go up to the different heights on a building of a building, or loading or unloading stock. Now this being a larger machine, a 60C, you can see from this picture here of the telescoping booms. They could travel on the road with this boom all the way down. Then for the job site, in order to get their height, they would extend these different sections out. And this particular machine had 3 intersections of about 20 to 25 feet. So that means that you had about a 60-foot extension. With the Evansville area being a highly developed area of coal, our Bucyrus plant in Milwaukee would build the machines and ship them down and erect them on the site. They were heavy enough that they could only be set up on the coal seam because of their weight. Now, this machine here, being a large muskie, they call it, it had cables up to 3 and 4 inch on this particular machine. that again, this was friction, but in later years, they went to electric clutches and brakes so that there was no, they could reverse the electric motors so that they could reverse their cables. That is a change from the friction machines where they use clutch and brakes. Okay, again on this machine, this had walkers on it so that it could move. It would walk like 4 large pads, 4 large feet. They would take step at a time and move it across the terrain. You can see here the size of some of these smaller machines. Here's a pickup truck. These were large enough at one time. Marion and Bucyrus traded back and forth in coming up with the largest machine, and at one time they were up over 300 cubic yards. That means you could back a pickup truck into the bucket and have plenty of room around it. Again, talking about these large coal mine machines. Here it shows 2 pickup trucks side by side. This is in a 115 cubic yard dipper, and it's would hold 200 tons of rock or dirt. This meaning that each swipe of this bucket would move 200 tons of dirt or overburden off of a coal seam or a copper mine or so on. This machine, you see the Peabody logo on it, which was quite popular in southern Indiana. This machine, give you perspective of it, 90 feet tall. That's taller than the Statue of Liberty. It was wider than an 8-lane highway. The power enough to serve the electric required to operate this machine was enough to serve a city of 15,000 people, and the outreaches of this machine was like a city block. So that explained what a machine like this could do, and it had to be, again, erected in the field, and if they moved to another coal mine, take it down and move it to another coal field. Okay, in the years of harnessing the wind for energy, Bucyrus had a plant in Pocatello, Idaho, and they got into building the propellers for these, and also some housework. You can see here this house on here would hold the shaft and generators, the 2 in most of these, that would have these different fan blades on that were close to 300 feet apiece. Again, this shows you the length of the blade stretched out section to section, and the interior, the core of it. This was bolted to a coupling which was bolted to a shaft. The Evansville plant, built in the early 1900s, was located on Claremont Avenue in Evansville, right a block or 2 off of Barker. The first buildings that were built was a office building and a foundry building, or forge shop they called it, right behind that building. Then they had 8 bays of machine shop. Across the back of the plant they had a plate and weld area, and then in the farm, the U, they had an assembly floor running north and south. As time went along, the object was the forge shop, the steel yard, the casting yard. The pieces would come in on a railroad car in this long bay be unloaded on the machines, do the different series of machine operations. If plate and weld was required, it was brought in on a rail car and bent or farmed or welded. These parts went to the assembly floor, to the rear end, the south end of the assembly floor. At that point, they had sub-assembly stations, meaning they would put the brake and friction housing together. They would build up the motor. They would build up the cab. And all of these things were done in a sub-assembly station, then put on the truck, which was the base of the machine. It would then be moved by overhead crane. Two overhead cranes would move these forward. They then would put on the tracks. They would put a boom on. They would take it out to the yard, which was just west of the building. They would test it under the different weight conditions, either crane by weights or a shovel by digging dirt. They then would bring the machine back in, disassemble it, paint it in parts. Now, the 88B or the 61 or 71B, these bigger machines would require like 3 to 4 railroad cars to ship. Or if they went by truck, you could have 6 or 7 trucks loaded with this weight. Now, which required permits. So a lot of the stuff was taken to the river and put on barges and shipped that way. But us being in the Midwest, close to the coal mines, we had the advantage of shipping repair parts to the coal mines either by truck or airplane or semi, and making us in a central location. Now, at one time, this plant was up to probably 1,000 employees. Then in the latter years, when they got more into parts buildings, parts selling, they built a bigger, what they called a PSR, which was a parts in process building. They built a big office building across the front, built a paint shop for the rubber mounted machines that had a downdraft system that they could drive in the back door, steam clean it after the testing, move it forward, paint it, and it was a downdraft system that all excess paint would go down into a waterfall underneath, and then had a drying room. So in the latter years, they got into a real good paint system. All of these pictures and demos that we showed you today were through the courtesy of the Antique Machine Society of Evansville, or Southern Indiana. They have been in operation since 1979 with their goal or their object to preserve antique or preserve machinery. Along with this, you have seen different pictures. They came from what we call the Scoop magazine, which has been a magazine for the company since its beginning. It was first put out quarterly, and then I think it went to semi-annually, and it was our method of society information throughout the plant, retirements, deaths, and promotions. In 1983, when the Bucyrus was sold to Continental EMSCO, the Evansville plant was, we operated under the Continental EMSCO, which is a drilling company. They was a subsidiary of LTV, which after a couple years, the drilling business went went out and they decided to sell the Evansville plant. So in 1983, we closed the Evansville plant and we formed what we call the Bucyrus Erie Continental EMSCO Retirement Group. We meet twice a year to get together with even the spouses of some of our buddies that's no longer along, attend the meetings, and they're twice a year. Again, the Scoop magazine was a magazine put out in all of the plants of Bucyrus for social promotions, deaths, different scholarship awards, and so on. Now, that magazine was done quarterly and then turned to semi-annually. Now, again, I'd like to mention how all of these objects have been brought, all of these photos and memorabilia has been brought together, and it's by the Southern Indiana Antique and Machinery Club. They were formed in 1979. That's open to people interested in the preservation of machinery and the lost my words.
And I was explaining there.
Here we have a pair of cast iron nameplates with the word Bucyrus on the one on the left, and the one on the right was the Erie Steam Shovel Company. Now this one on the right has a patent of 1918, January the 22nd of 1918, which can show you how the Bucyrus Erie became a name. This being the famous water tower of Bucyrus Erie, it stood next to the Ford shop, one of the original pieces of Evansville. In January of 1982, Bucyrus Erie, or the Evansville division of Bucyrus, was sold to Continental EMSCO, and this is a flyer from them, the green triangle.
Okay.
Being on the assembly floor, this was a common sight the day of a machine to be shipped. All last minute things to be done, the engine ready to pull it, guys painting, putting on parts, pulling off parts, and so on. And you can see by the bottom there it says 3:30 on sold machine day. Here we have a picture of the outside yard, different boom sections, different castings in tubs in the rack system there. These parts were being ready to be brought in to be machined. Here's a picture of Claremont Avenue looking east. You can see Wright's Hill in the background. You see the employee parking lot. This was a spur that we brought our material in, and we shipped our material out to the L&N. This being the machine shop looking south, Bay 1 through Bay 4. You can see there a large turret, a large engine lay on the right side there. 444 turned a lot of the axle work. 6, where they had the turret, the screw machines and small drill presses. This is Bay 4 through 8, looking back at the plate and weld area. Again, drill presses, milling machines, planers. Bay 5 had the gear cutting machines, the broach machine, and a couple vertical shapers. Bucyrus was quite involved in the parts repair business, and they would ship around 1,000 pounds a month in spare parts. These were shipped by truck or air to the coal fields. Picture of some links, some rods in the boxes there, which were for cylinders.
Okay.
Another view of the parts area. You can see the 1950 model cars in the background on Claremont Avenue. This being a mock-up of a bucket, a dragline bucket or a shovel, a dipper, it has teeth on, and as this is what goes into the rock and the dirt to dig through it. As these wear down, these teeth are replaced. They have a slip joint in there and they drive a wedge in to hold them in. Now some of your buckets have welded teeth. Now to show the size of cable, this being around, see my hand, this being about a 5-inch cable with 1, 2, 3, 4, 5, 6, 7 inch and a quarter, inch and a half cables spun into it. This is a piece of a electric cable that's used to power the big electric machines. This is about 3 inches in diameter. You can see the different cables within that. Just a small nut here, about the size, like about a 3-inch coarse threaded nut, and a large end wrench. This here being a steam whistle. It was used around different machinery, not especially on machines, but the whistle was used for starting times and quitting times and so on.
These are the jackets used by Bucyrus Erie employees 1981.
You're going out to your car. Here's a couple of things.
Okay, thanks.
Well, thank you.